This is the Math 1113 Zoom meeting for April 13th. We're doing section 7.3, and we are going to bury you in trig formulas. I'll show you the first two or three maybe, but after that, the gibberish, they throw so much at you, it just comes across as kind of gibberish, and you can pretty much look up the ones you need to work the homework that you need. They kind of refer to the problems that you're going to need. You can kind of see the names. They're called double angle formulas, half angle formulas, evaluating expressions involving inverse, and product sum formulas. All right. They work off your basic ones. They work off your 7.2 formulas. I'll show you the kind of examples of the kind of manipulations to get these new formulas. The first type 1, we'll call them double angle. Okay, starts off with sine. I'm going to use an x and a y instead of an s and a t. I have an x plus y, if you remember, was a sine, went sine first, cosine second, plus cosine first, sine second. Okay. Now we're going to set the angles equal, which means y equal to x. I'm going to do this really slow, the first one, and then maybe speed it up for the rest of them. That's going to give you a sine of x plus x. If y equals x, so I'm going to put it in x where there's a y. That's going to give me a sine of x, a cosine of x, plus a cosine of x, a sine of x. So everywhere there's a y, I stick in an x, here, here, and here. Okay. Well, basic algebra, x plus x, 2x, hence the name double angle. By setting the angles equal, in effect, you've doubled it. Well, that's going to give you a sine x cosine x plus cosine x is sine x. Can you tell these are like terms? And they double. So one of them plus one of them equals two of them. I'll rewrite it down here. 2, they usually write the sign first for whatever reason. Twice times the sine of x times the cosine of x. It's almost like the 2 pulls out, but you have a product of the sine of x with the cosine of x. I could plug into the calculator, but I did that plenty in 7.2. I hope you believe. Notice you don't do difference. Meaning a sine of an x minus an x. If you set sine of x minus y, remember there were formulas for that. It just changed that sign to minus. And you set y equal x, well, you'd have sine of x minus x. That's a sine of 0. And that is equal to 0. You get nothing. So we only are concentrating on the sum formulas. This is used a lot. Used a lot. All right, the cosine of 2x is used a lot too. I'll give you a cosine of 2x. All right, but let me start from basic formulas. Meaning you have a cosine of x plus y. Remember that went cosine first, cosine second, opposite in the middle, sine first, sine second. There are actually 3 versions of this. This is going to be version 1. Set your y equal to x. And once again, cosine of x plus x, cosine x, cosine x, minus sine x, sine x. Well, here's your double angle, 2x, cosine squared, cosine times cosine is cosine squared, sine times sine is sine squared. We'll call this version 1. There's 2 other versions. Sub in that a cosine squared is equal to 1 minus a sine squared. And we get that a cosine of 2x would be equal to 1 minus a sine squared. Subbing this in for the cosine squared minus sine squared. These 2 are alike. You get 1 minus 2 sine squared. Call it version 2. I don't know if this lines up with, but I'll point these out in the book. I don't know if I'm doing the exact order the book does them, but all right. Sub in sine squared 1 minus cosine squared up here. Cosine of 2x then would equal cosine squared x minus 1 minus cosine. That's an x. I don't know if you can see the distribute, you get a minus 1 and minus a negative, so that's a plus. So cosine squared there minus negative cosine. Speed it up a little bit. That's twice the cosine squared minus 1. Version 3. Let me summarize so far. This is a lot of gibberish. A sine of 2x twice sine times cosine. Cosine of 2x. Cosine squared minus a sine squared. Remember, if it's a plus, it'd just be 1, but it's not a plus, it's a minus. It's also twice the cosine squared minus 1, and it's also 1 minus twice a sine squared. All 3 are correct. They're all equal. All right, I can derive a tangent of 2x. But it's not useful. But I'll go ahead and do it. You'd have a tangent of x plus y. If you remember, I'll start with standard x plus y. Remember, it distributed on top, but you went 1 minus the product. All right, see if you can set y equals x and see what you're going to get. Well, you're going to get x plus x. That's a tangent 2x. Now, never forget, it's also a sine of 2x, and this is varies over a cosine of 2x. And you can use these formulas up here, and that's done a lot. It's equal to this. Never forget that. But directly from here, that's a tangent x twice tangent x. And if you got an x there, tan x is tan squared. 1 minus tan squared of x. I can show these to you on the next page. There they are, twice sine x cosine x, 3 versions of cosine 2x, and then the tangent of 2x. I've never really ever seen it used much. Okay, I can go down through and maybe we'll do some examples of these out of the homework. They'll actually be identified by these before we charge into other formulas. Take a look at the homework. Page 597, here's an example of what they're going to have you do. Page 597, number 3, say. Here's what you're given. That a sine of x is 5 over 13, x in quadrant 1. And these are more like projects than problems. Find sine 2x, cosine 2x, tangent 2x. All right, so we're going to draw our coordinate. It's a quadrant 1. Sine is opposite over hypotenuse. Hope you realize that's 12. All right, and so this is our x. All right, well, it's plug and chug. First one, sine of 2x is twice your sine. Sure you have this memorized. Okay, it's just basically plug and chug, matter of knowing the formulas and plug in and chugging. So twice your sine is 5 over 13 and your cosine is 12 over 13. All right, if you multiply out your top, 2 times 5 is 10, times 12, that'd be 120. 13 times 13 is 169. And all it just really means is that if you double x, that means you're going to wind up into the second quadrant. Your sine, is your y leg there, will be 120 over 169. You could get the decimal for it. But that's the length of the y coordinate when you doubled the x. That's all it means. All right, you could get the decimal for it, I'd like to say as well. Let me go to the next page. We'll do a cosine of 2x, and you have your choice of the 3 different versions. On a cosine of 2x, you can use any of that picture, so leave that up. Any of 3 versions. All of them will give you the same answer if you work it out correctly. I guess I'll just use cosine squared minus sine squared. Right. Well, cosine squared, if you remember, was 12 over 13, but that's squared. Sine squared is 5 over 13, and remember, that's squared. So you're going to get 144 over 169, subtract 25 over 169. Should be able to do that in my head, but I'll just 144 minus 25, 119 over 169. And all it means is, again, double x, 2x, and your x coordinate is 119 over 169. It's your x coordinate at twice, and it's going to be using the same letter for angle as this, at twice 2 times the angle. Just write down words. All right, 3, tangent of 2x. Okay, we can use that it was twice the tangent of x over 1 minus tan squared. Then you got to figure out your tangent and everything. A little complicated. So I'm going to use, especially since they had me work out sine of 2x and cosine of 2x. Sine 2x divided by cosine 2x. Your sine of 2x was 120, 69, and your cosine of 2x is 119 over, it's almost a 45-degree angle. You see, if these had been equal, it would have been a 45-degree angle, but it's not quite. It's very close, though. That's going to give you 120 over 169 times 169 over 119. You're going to be slightly bigger than 45 because you're bigger than 120 is slightly bigger than 119. It's going to wind up 120 over 119. That's my tangent of 2x. The ratio of y to x at twice the angle. It's the ratio y over x at twice the angle. All right, that's the kind of stuff they have you do, and they want you to use the formulas. There's a lot of stuff here, so maybe I should be getting along here. Let's see, half angle formulas. To get to where you're getting those, you have to kind of go through, it starts here. You have to kind of go through these lowering power formulas. Okay, so this really starts with the three versions of cosine 2x. Really, the second two versions. So we had cosine of 2x, 1 minus twice sine squared. Okay, solve for sine squared. Speed it up a little bit. Can you tell you got to subtract 1 and divide by -2? It's going to be a cosine of 2x, subtract 1 and divide it by -2. But we don't like the negative, so they like to switch the order. So we're going to use sine squared of x is 1 minus cosine of 2x, all divided by 2. This is called lowering powers. You have a sine squared and you've lowered it to a first power here. You had to switch it to a cosine and double the angle, but this is called power reduction, lowering powers. All right, if you do a cosine of 2x was twice cosine squared minus 1, solve cosine squared, can you tell you're going to add 1 and divide by 2? You're going to go cosine of 2x, add 1 and divide by 2. For whatever reason, they like to write the 1 plus first. Cosine of squared x is then 1 plus cosine of 2x divided by 2. So this is where they get these first two formulas. I'm not going to write down the tangent version. You can divide it. You'd almost see it in your head. If you take your sine squared and divide it by your cosine squared, the 2's are going to cancel. You wind up with this top over that bottom, which is what happens. Okay, lowering powers. Now, to get to what they call the half angle formulas, solve, take this formula, your sine squared. Notice how similar they are. They both work out for cosine of 2x. That's because of the versions, different versions of cosine of 2x. And the only difference between them, a sine squared has a 1 minus and a cosine squared has a 1 plus. Otherwise, they're identical formulas. All right, so take the first one here. Solve for sine x. That's pretty simple. You're just taking a square root. Sine of x, and when you take a square root, you need plus or minus the square root of 1 minus cosine of 2x divided by 2. All right. The x is just a placeholder. So when I can call it anything. So if I want a half angle, set or x to x divided by 2. The book uses u divided by 2. If you want to directly match about, I'll use u divided by 2. So I'm going to have a sine of u divided by 2, and there's my half angle. That'll equal plus or minus square root 1 minus cosine of 2, and then u divided by 2. If I replace x with u over 2, I got to do that x with u over 2. You see, that's over 2. You see what happens, the u's cancel, and you get a direct angle here. Sine of u over 2 is equal to plus or minus big square root 1 minus cosine of u all divided by 2. Okay, I can probably tell that the gibberish is getting overwhelming. So the cosine is absolutely identical. You do the same thing, but notice you just have a plus because the cosine had a plus in the formula. Cosine u over 2 has a plus. Sine I just did, it has a minus. And it turns out you can get these different versions of tangent u over 2, but again, I've really never seen them used. So there's a bunch of problems with half angle formulas. Why don't we try a couple examples of those before we finish with product sum formulas. So page 597, try 17. Sine of 15 degrees. Right, the trick is to match to sine of u over 2, which means u over 2 is 15 degrees, and u would have to be 30 degrees. Multiply both sides by 2 times 2, 30 degrees. The u itself would be 30. This is half of it. Okay, I'm going to write in the formula big square root plus or minus the big square root 1 minus cosine of 2u all over, I'm sorry, not 2u, straight u, my fault, straight u. So a sine of 15 degrees is equal to plus or minus big square root 1 minus cosine of 30 degrees. See, if you got half of the u itself, u itself right there would be 30 over 2. Well, a cosine of 30 is equal to root 3 over 2. And you wind up with some of these nasty expressions. A sine of 15 degrees, big square root 1 minus the square root 3 over 2 all over 2. Now, the trick is to pick the plus and minus. Either plus or minus, and it works by the 15 degrees and sine being the y coordinate. 15 degrees is in quadrant 1, and the sign is positive. Positive. So that makes sine of 15 degrees equal to positive, and you don't have to write the positive, 1 minus root 3 over 2 all over 2. Now this will probably not match the book, but it's good enough for me. I don't think I want to do the next 15 steps of algebra to match it down to what the book has. You could get a decimal for this and match the decimal in the book. All right. 29, something like 29, uses the double angle formulas backwards. Page 597, 29, part A. Simplify twice a sine of 18 degrees, a cosine degrees equal, well, if you notice, that matches twice a sine of x, a cosine of x. Well, that would have to be a sine of 2x. Well, if x is 18, 2x would be sine of 36. So the answer, sine of 36 degrees. You could get a decimal, didn't really say get a decimal. That's not a circle number. Between 30 and 45, it's somewhere, it's bigger than a half because sine 30 is a half, and it's lower than 0.7 because that's the sine of 45. You could punch it if you wanted a decimal for it. Okay. Something like 37 mirrors the very first section. They give you a situation and they want you to do a sine of x over 2, a cosine of x over 2, and a tangent of x over 2. Sine of x is equal to 3/5. 0 degrees less than x less than 90 degrees. That's basically quadrant 1. Did I tell you quadrant 1, they give you the limits of the angles in quadrant 1. Find over 2, a cosine of x over 2, a tangent. And again, if you find sine and the cosine, we can just divide them and get the tangent. This will equal sine x over 2 divided by, didn't write that right. A tangent of x over 2 will equal a sine of x over 2 divided by a cosine of x over 2. So since they've had me do sine and cosine, I might as well just divide them rather than using a separate formula for the tangent. Okay, we're in the first quadrant. Sine is 3 over 5. Cosine would be 4, or the x-leg would be 4. I hope everybody knows that. I'm sure you have, this is x. See, in effect, for sine of x over 2, you're taking x over 2, you're taking half of x, and we want to know what the y leg is. I'm dying to know, the suspense is killing me. Sine of x over 2, then I'm sure you have memorized, is plus or minus big square root 1 minus cosine of x all over 2. Okay, well, cosine of x is 4/5. So your sine of x over 2 is then plus or minus big square root 1 minus 4/5 all over 2. And yeah, there's a lot more. I mean, you can simplify this a lot more. Maybe I should. 5/5 minus was 1/5. You're going to have 5/5 minus 4/5 is 1/5 plus or minus big square root of 1/5 over 2. And that's going to be big square root of 1/10, which is going to be plus or minus 1 over the square root of 10. You don't have, it's hard to know where to quit on this stuff. All right, now a cosine of x over 2 is going to be really similar. Just remember, it just changes to a plus sign. Oh, by the way, it's positive in quadrant 1. Plus minus big square root 1 plus cosine x all over 2. Well, that'll be plus or minus big square root 1 plus 4/5 all over 2. On the screen here. All right, well, that will be 1 plus 4/5 plus 4/5 is 9/5. Again, it'll be positive quadrant 1. 5/5 plus 4 is 9/5 over 2. That'll be plus square root of 9/10, which will be big square root of 3, all 3/10. It will be 3 over the square root of 10. Square root of 9 is 3 out of the root. Root 10 stays underneath. If I want a tangent of x over 2, then I can do sine, cosine, which means I can do 1 over root 10 divided by 3 over root 10. Can you tell that's going to be 1/3? Root 10 swings around, cancels the root 10, 1 over 3. Yeah, I'm not checking answers, so if I'm screwing these up, let me know. There's so much in this section, I'm just basically trying to get through it. Try to show you all of it in a reasonable length video, so if I have screwed something up, by all means, let me know. All right, so how about one like 43? You basically have a sine of twice an arctangent x. Find a formula, an expression in x. All right, well, the 2 gives it away that you're going to do a double angle. So that will going to equal a twice a sine of whatever this is, arctangent x, cosine arctangent x. This acts like your theta or your sine 2 theta, sine 2 u is twice the sine of u, the cosine of u. It's like the 2 comes out. All right, draw a triangle. X over 1, so x, 1, and square root 1 plus x squared. Leg squared, add them up, get the hypotenuse. And you are going to get twice. Your sine is x over the square root 1 plus x squared. That's this piece is this. And your cosine is 1 over the square root 1 plus x squared. So this piece is this. And you're going to wind up with 2x on top. 2 times the x goes on top, and you square root identical. That takes away the root 1 plus x squared. Do these go in the category they're so easy when I do it? Watch me screw them up. I never do anything in advance, so if I've screwed them up, let me know. Okay, what about one like 47? Take a sine of twice arc cosine of 7 over 25. Find the exact value. Once again, that's going to be a double angle. You're going to take twice the sine of arc cosine 5 and cosine of the arc cosine of 7 over 25. Meaning it's twice the sine of this times the cosine of this. This is easy. 7 over 25. All right, so I need a triangle. Arc cosine, that would be 725. And this leg is going to be a big square root of 25 squared minus 7 squared. I think this could be a big square root of 625 minus 49. $576, I think that's even. it might be 24. Answer. Yep. 24. So your sine 24 over 25. This piece is this. So you're going to equal twice times 24 over 25 times 7 over 25. So you're going to get 14 times 24 or 48 times 7. However you want to do your top, but 2 times 24 times 7. 2 times 24 times 7 is 336. 625. Well, what the heck? I'll check one with the calculator. Okay, probably be safe. We want radian mode. All right, radian mode. Okay, sine twice second cosine 7 divided by 25. 5376. 76. 336 divided by 625. Drum roll. Bingo. It makes perfect sense to me. Okay. Moving right along. How about 51? Find cosine of 2 theta when your sine of theta is negative 3/5 and your theta in quadrant 3. Again, remember there are 3 versions of this. I'm going to use cosine squared theta minus sine squared theta. I guess just, I don't know, just used to using it. All right, let's draw our picture. We're in quadrant 3. Sine, that'd be a negative here, negative 3. Hypotenuse is 5. This would have to be negative 4. 3, 4, 3, 4, 5. But in your quadrant 3, both x and y are negative. Okay. Your cosine theta then, I'll just write them down here. Your cosine theta is negative 4/5, and your sine theta was given to be negative 3/5. So plugging and chugging, you're getting a negative 4/5 minus a negative 3/5, which is giving you 16 over 25, subtract 9 over 25, 7 over 25, which means you've doubled. This is theta around to here. Doubling it would probably throw it into the first quadrant. And your cosine of, that would be 2 theta angle, and your cosine, your x coordinate is positive in either quadrant 4 or 1, depending on which one it threw it into. Okay, now by 55, we're into a new set of formulas. Product sum formulas. Okay. Page 595. I'm not going to write all these down. I don't have them memorized. I have to look them up. But they are ways you have a product of these combinations. They expand out with all of them with a big 1/2 factored out, and then a sum or difference of these combinations. They're pretty easy to prove, actually. You can plug and chug into your sine of u plus v, sine of u to minus v, do the algebra, and the only surviving term will be whatever combination this is, but I won't take the time. A lot more gibberish, and we'll want to work as many as I can. Hopefully you believe. And then there's actually page 596, sum to product, where you can take different combinations of sines and cosines added or subtracted, and then they multiply out. And it turns out you can like average, some of them average the angles, some of them you difference the angles divided by 2, etc. I don't have these memorized, but if they want me to use them, I just look up the correct combination and go. They're pretty easy, plug and chug. So if I go to 55, page 597, it has sine of 2x, cosine of 3x, right as a sum, it says. So I go to page 595, and I see a product of a sine and a cosine, which is the first one. Book has sine of u, cosine of v being a big 1/2, sine of a u plus v plus a sine, just can't squeeze it on, u minus v. Okay. Sine times the cosine expands out to this. So I've copied it down exactly the way it's in the book. The u is 2x, the v is 3x. So plugging and chugging, I get a big 1/2, a sine of 2x add 3x, plus a sine of a 2x minus 3x. You wind up in effect adding them, sine of adding them, and sine of subtracting them. Well, that's going to give me a 1/2, a sine of 5x, plus a sine of a minus x. And the only thing you can simplify on this is that this is equal to a negative sine of x. Remember, sine is odd, so a negative comes out. If it was a cosine, you could ignore this. So your final answer is a 1/2, 5x minus a sine of x, and you're done. Don't get a sine of 4x. Sine of 4x, no, if you want a right answer. These are unlike terms, they do not combine, their arguments are different. So that's the kind of stuff they have you do there. How about, 61. $597. Take a sine of 5x and add a sine of 3x. Okay, you have no idea how many people will get a sine of 8x. Don't do this if you want a good grade. And I know you all want good grades. Please resist doing that. Okay, we're going to follow Formula 1 here. See that sine of x plus a sine of y? Sine plus a sine. I'm going to hope you can follow it so I can speed it up a little bit. You're going to get a 2 and a sine of your 5x add 3x divided by 2. Now it's based on the line. You're going to get a cosine of your 5x minus 3x and divided by 2. Hope y'all can follow that. Twice, that's a sine 8x divided by 2, cosine of 2x divided by 2, You can simplify both of these. Twice a sine of 4x, a cosine of x. 8 over 2 is 4, and 2 over 2 cancels. Questions about that? All right. 67 does this with numbers. Find value of twice 52.5 degrees sine 97.5 degrees. Okay. Sine times sine, that would be the last one here. Page 595, a sine of u, a sine of v goes a big 1/2. Cosine of u minus v minus cosine of the sum. So this would equal twice. You got here's your u, here's your v. You'd have a 1/2 following this formula. That's why they put a 2 in front, cancel your 1/2 out of the formula. A cosine of your 52.5 degrees minus 97.5 degrees minus, and cosine of 52.5 degrees add 97.5 degrees. Wonder if they've made these come out circle values. 52.5 minus 97.5. And all of a sudden, my calculator is on the blink. It turns off. Okay. 52.5 minus 97.5. Negative 45. Yep. I wonder if this is 135 then. 52.5 could have called it back and add 97.5. 150, okay. Minus cosine of 150 degrees. Add 97.5. So cosine of your negative 45, it's equal to cosine of 45, which is your root 2 over 2. And minus, and your 150, you're into the second quadrant, 30 degree equivalent, negative root 3 over 2. Negative root 3 over 2. So this is going to go root 2, add root 3, and divide it by 2. I could punch that and punch this and see if they're the same. Should be. But we're getting close to an hour, so I'll let y'all do it. And then we get into identities. And I have my assignment somewhere. Oh, over here. See how far we go. Something. Oh, that's 7.2. 7.3. Here we are. Went through 81. Okay. We went through 81 and then 97 and 99. Okay, so the identities here, most of them again follow, if you can figure out which formula they're referring to. There shouldn't be too bad. Page 597, 73, a cosine squared of 5x 5x is equal to a cosine of 10x. This one's so easy, it's hard to know what to do. Verify. Well, make this come like your u. Make this your u, and you have cosine squared of u minus sine of u is equal to cosine of 10 times x, cosine of, it's hard to know what to do. Let's see, following u, it would be cosine of 2u. So that would be cosine of 2, and then the u is 5x. And there is your cosine of 10x. It's almost so easy, it's hard. All right, how about 75? A sine of x, add a cosine of x, squared is equal to 1 plus a sine of 2x. Well, let's FOIL on this. Can you tell you're going to get a sine squared x, twice a sine x, a cosine x, plus a cosine squared of x equals this. Sine squared plus cosine squared, that's your 1. And twice sine x cosine x is the definition of sine of 2x. Sine of 2x. Okay. I probably make it look way too easy, but I guess that's because I know instantly what formula to go to if you have to sit and think about it for a while. All right, so I had to go down through 81 here. I'll let y'all mess with them. That'll give me more to do on Friday. Left off a lot of those. And I think the last two were 97 and 99. What were those about? Okay, 97. Show that a sine of 130 degrees subtract a sine of 110 degrees comes up negative a sine of 10 degrees. All right, well, let's plug in. If you look, we need a sine minus sine. That's the second one here. So I'm just going to copy it down. This is like your x, this is like your y. So it's going to equal twice a cosine 130 x plus y divided by 2. In other words, 130 degrees add 110 degrees divided by 2 times a sine 130 degrees minus 110 degrees divided by 2. All right, we're going to see if we can't wind this down and make it come up negative 7 sine 10 degrees. Twice cosine 130 plus 110 have to be 240, wouldn't it? 40 degrees divided by 2. Sine, wouldn't that be 120 degrees divided by 2? All right, well, 240 degrees divided by 2 is 120 degrees. Sine of 60 degrees. I was going to plug in my numbers, but how do I show that that's negative sine? And if I do, how do I show this? That's a root 3 over 2, negative 1/2. waste y'all's time here. Just a minute. Okay, found my idiot mistake. 130 minus 110 is 20 degrees, not 120 degrees, which makes this sine of 10 degrees. Okay, a cosine of 120 is negative a half, twice negative a half, and then sine of 10 degrees. And then sure enough, your twos cancel, and there's your negative sine of 10 degrees. Idiot. I am an idiot mistake. I don't know if anybody watched this video long enough to find that mistake. But in any case, I screwed up. Yeah, simple arithmetic error there. It's 20, not 120. Okay, let's see. That's pretty much examples of about everything. So I think we will call it there, and there's another Zoom meeting at 10 a.m. on Friday. Hope to see you there. Thank you.